Appreciate everybody coming to PyHawaii. If you want to get on the Wi-Fi, the SSID is there on the whiteboard. The login and the password are on the whiteboard as well. We do want to say that we're very thankful to the Iolani School for kind of donating their space to us for this purpose. We appreciate kind of their support to what we're trying to accomplish in teaching people Python. Going to cover just a couple of things about PyHawaii and some things that we'd like to do, and some things that are coming down the pike. Sign-in sheets going around. We are on the interwebs. The mic is live. Lord willing, people can hear me. So we are on YouTube. If you want to kind of see the things that we've done in the past 4 or 5 sessions, they're on YouTube, and if you search for PyHawaii, you can find them. I try and clean them up a little bit after the fact, get some of the cruft out of the beginning at the end. Most of them are about an hour or so. When we finish today's conversation about pandas and matplotlib, if we have enough time left over, we're going to go over a puzzle. So a couple things that we're interested in doing with PyHawaii. We have been discussing doing another mini conference. Back in November, we had a one-day conference. It was about 8 hours in length, got a bunch of folks together. We played some games. We had a number of folks speak. So we're very much interested in trying to do that again later in the summer. We did it in partnership with the Honolulu Community College and the Pacific Center for Advanced Technology Training. We'd like to see if we can engage with even more folks across the environment in Hawaii. The data science and data analysis series that we're working on right now is probably going to wrap up in about 2 more sessions. I think I have 2 more kind of pandas-oriented conversations. After that, I think we're probably going to switch gears a little bit and go back toward some things that might be a little more geared toward beginners. Although what I think I would like to try and do with PyHawaii is have for each session something geared toward beginners and something geared toward advanced. I don't really like it when, for example, half the audience is like all advanced and there's no beginners, etc. We lose out on good opportunities to network and to talk to each other and to learn from one another. So look for some possible changes in how we kind of deliver some of our material. Considering putting out kind of a survey to talk to folks about locations and timing. 5 o'clock in the afternoon in Hawaii may be a smidge too early, maybe too tough for people to kind of get here. This location, although we love working at the Iolani School, this location may not be the right one in terms of like where it is in relationship to where folks have to commute to or from. So if we send a survey out to you, we hope that folks would take a few minutes and kind of look at it and give us some good feedback. And with that, I wanted to dive into how we can do data visualization with some of the scientific libraries that Python has available to it. So I'm going to pull up these guys right here. And there. All right. There are a number of visualization libraries that are available with Python. We're going to look particularly at one of them tonight. It is not the only one. The one we're going to cover is matplotlib. We're going to look at 4 different types of plotting that you can do with it. I will point you toward an example or 2 of another library called Seaborn, and then I'll mention briefly a last library called Bokeh, and we'll talk about kind of the benefits of each of these. For tonight's conversation, while we're looking at matplotlib, something to kind of be aware of, some of the other libraries out there will have kind of very similar mechanisms for causing your graphs to appear. So if you can kind of figure out one of them, you're well on your way to trying to figure out some of the others. So the graphs we're going to look at tonight, one of them will be a scatter plot, and it's kind of here in the foreground. You see a bunch of little circles. They're all in various locations, depending on the value between 44 and 51 and a value between 7 and 13. Each of the circles is a different size that might represent some data point about whatever it is we're studying. And each one of them is a different color, which might represent essentially a 4th data point about whatever it is we're studying. And as we go through and generate this graph, we'll talk about where the data comes from and how we put together. The next one is going to be a set of subplots. We have two plots on the same sheet of paper, as it were. They can potentially be related to one another. Matplotlib has the capability of putting subplots together and having kind of the underlying data be correlated in certain ways so that things will line up well. And we'll see how that plays out. I've got a horizontal bar graph. It's all in kind of pink color. Might be a little hard to see, but on the far right side, we've got these little error bars to show just how much potential error is in that value that's represented on the horizontal bar. And then the last one, we've got a simple histogram. And then we've plotted over that as kind of an overlay, a probability distribution function in a red dashed line that kind of evens this out. And we'll talk about how we got each of these and how we kind of set them up. So let's get started with that. I think we're probably going to do the horizontal bar chart first. And let's see. There we go. Yep. All right. So we'll do the horizontal bar chart. IPython, get IPython to load up. Say run. And I've got a demo script that helps me move through each of the scripts that we generated and in a step-by-step fashion. All right. One of the first steps that I'm going to do for this particular graph, and you don't have to do all the steps I show you for every graph, but for this one, we're going to import NumPy, and I'm going to import it with an alias called NP. That'll make it easier to type. I import a module out of the matplotlib package. It's called matplotlib.pyplot, and I give that an alias PLT because that's, again, too long to type. And we import pandas as PD. All right. The next step, I'm going to use the pandas library, and it has a read CSV function. And I'm going to read in a CSV. This CSV is called log file CSV, and it's in a folder nearby. A couple things to note. I give it a names argument, and the names argument is my way to tell pandas that I want to name each of the columns. The first column will be name, the second one will be email, the third one will be from IP, to IP, etc. So when pandas reads in this data from my CSV, each column is going to have a nice name, and I can refer to that column by name. And lastly, I tell it to use a particular column. I really only want one piece of data out of this CSV. I want it to take the first column that it comes across, name, and store it. And I will store it and give it a label called df so I can refer to it later. So let's do that. And if I bring in df and I ask IPython to show df to me, you'll see I read in a single column. It happens to have 10 rows. These are superheroes from the Justice League universe, and we've got a couple of duplicates. Kara Zor-El shows up 3 times, and that'll be important later in some of the things we do. We're going to kind of clean up some of the duplicates and stuff. The next thing I want to do is I'm going to take some data, and I'm going to store that data in a brand new column. So the data that I want to do comes from a function in the NumPy library, and the function is called rand. And if you give rand a number, it will produce that many random numbers for you. In order to figure out how many random numbers I want, I tell it, look at this data frame df and tell me how many rows are in it. And it'll come back, and the length function will spit out a 10, and it will produce 10 random numbers. I take each of those numbers and I multiply them by 6.5, and then I add 42 to them. So what's going to happen is, instead of being numbers from, like, I think it was 1 to 0 or 0 to 1, it'll be numbers from about 48 to 54 or something like that. And as it creates these 10 numbers, it will store them in a new column called fan rating. And if I look up df and ask for that again, we see now I've got a brand new column. It's labeled appropriately, and it shows a sequence of random numbers anywhere between about 42 and, in this case, they stop at about 47, I think. All right. So, all right. I mentioned earlier that some of these rows were duplicates, and we want to take care of that and get rid of some of that. So what we're going to do is we're going to use a function that's attached to each and every data frame. It's called drop duplicates. I'm going to say, look just in the name column, and if you see any duplicates in the name column, I want you to get rid of them. I give it a couple parameters. The first one is do it in place. I want you to just take whatever data I have and obliterate it. I don't need you to make a copy to keep the original intact. So we say in place equals true. And then I have the ability to choose where in the duplication process I want to kind of keep my valid data. You can have it take the first, take the last. So for example, if I had 5 rows and row 2, 3, and 4 were duplicates, I could ask it to keep row 2 or wait until it gets to the end and keep row 4. Apologize, I'm trying to kill my phone. All right, so it doesn't make any more noise. In this case, I want to keep the last item in the row. And when might you do something like this? If you're doing maybe reading of log data, you've got a bunch of log data to show things that have happened on your network, and you just want to keep the most recent piece of information associated with a particular user. You don't care what he did 5 months ago, but you really are interested in what he did most recently. That might be a case where you take the last item in the data set. All right. So when we run this, we should get an error message in this case. And this sometimes shows up. And it's not really an error message. This is more of a warning. So as we read across, we'll see that it tells me in my script, section 7 or line 7, there's a future warning. And it says the take last equals true keyword is being deprecated. They're going to stop using that. They're going to change that to keep equals last instead. So you can choose to keep first or last, whichever. You'll see these types of warnings, especially with some of the scientific libraries, as they kind of formalize how some of the modules work. They might want to standardize on language, because what if Joe over here made one module and Fred made another one, and they had very similar functionality, but they have completely different naming conventions. So they may work together and kind of formalize, let's use this naming convention. But they don't want to break everybody's code. So they'll put in a deprecation warning, and they'll say, in the future, this will break. We're going to drop support for the take last keyword. Prepare yourself. Fix your code now. In this case tonight, I didn't worry about it. I wanted you to see the error so we could have this little conversational point. Let's go. All right. And by the way, if anybody has any questions, feel free to ask them. Ria, I think, is watching the chat room. So if somebody out there in Ethernet land has a question, we have someone watching the chat room, and Ria will kind of flag me down. So on the next slide, as it were, I'm going to create a simple function. The function's called fNameOnly, because I want to take the names of all of my superheroes, and I want to get rid of the last names. I want to keep just their first names. So I will end up reading in a full name. Once I have that full name in my function, I'm going to use the split method on strings, and I will split the string any place that there is a space. And that produces a list. The split function always makes lists, and I'm going to use the indexing, and I'm going to say, take the 0th item out of the list. And by 0th, I basically mean first. Python counts from 0. Once I grab just the 0th item out of my list, I'm going to assign it a label called fName for first name, and my function will return that. And we're going to create a new column in my data set, and it should have nothing but first names in it. So I go into my data set, I look at the data frame, I find the name column, and the name column has a map function associated with it. I drop the name of my function in, and I take the results of that and I assign it to a column called fName. And if I run that, My data frame should end up with a brand new column in it. So let's look at the data frame. Now it's got 3 columns, F name, and sure enough, I'm lucky it has only a first name in it. For later use, as I do the graphing, I'm going to want to use just those first names for a purpose. So I also run this snippet of code. It says, look in the data frame, find the first name column, and take just the values out of it and store those. And they'll store them with a name called people. And what that will be, when it stores just the values, it will store it as a NumPy array. Kind of like a glorified list, a list with a little additional power behind it. All right. Next, I'm going to create a range of values using NumPy's aarrange function. I don't know how they pronounce that. I'm going to call it aarrange instead of arrange. It probably stands for array range. I'm going to tell it that I want a certain number of values. So I'm going to look at the length of my list of people. I'm going to ask it how long is that list and produce that number of that many values. And it should start at 0 and count up until it gets to however many people we have. And then I'm going to store that with a label called ypos. So those would be my y positions on my graph. And I want to grab just one of the columns out of my data frame. So I'm going to say, look at the fan rating column and store that off as an element called performance. So let's look at these two things. So let's look at what ypos is. I'm going to ask Python to use its type function to tell me what this thing is. All right? And again, it turns out to be a NumPy array. And then let's look at what performance is. Performance happens to be a series. It's one of these data elements that's in pandas. So you might ask, well, why do we care? One of the things that I find is people are working with both the scientific libraries or folks who are getting started with Python is they often don't know what they have. They don't know that this is a list or that this is an array or this is a series. And if you do not know what you have, you don't know what you can do with it. You say, well, what does that mean? So if I take ypos and I put a period after it, and in IPython I hit tab, you will see that there are both behaviors and characteristics, methods and attributes associated with ypos, and I can have it do things. I can have it do a cumulative sum of all of the data that's in this ypos array, or I can have it do a standard deviation calculation against all of the items in it. Now, if I go look at something like a standard list in Python, you'll see there's a much smaller number of things that you can do with that. You can extend it or append it to it. You can pop things off of it. And as we looked at performance, that was a series item. And we can see that there is a huge number of things that you can do with a series item from pandas. So it's really important to remember and understand what you have. What did your data become anytime you manipulate it in some way? That gives you clues as to what you can then do with it. All right, so next, I'm going to take the matplotlib libraries pyplot that we imported earlier. We gave it an alias of PLT. And in the PLT library, they have this function called bar H, which stands for horizontal bar chart. And I'm going to tell it, take all of my Y position items that we created earlier, and take all of my performance ratings that we came up with earlier, and plot them on a bar chart. And then I'm going to ask it to show that bar chart to me. And there we go. So a couple things to note. It goes from 0 to 50 on the bottom, and that should make some level of sense. When we did that random numbers, we got numbers that went from about 42 to 49 or something like that. And you see that all these bar charts kind of end in that range, between 42 and 50 somewhere. On the far left side, they've got this kind of Y index, and it starts at 0 and goes up to 8. That's probably not what we want. We might want to see the performance of each of the superheroes, so we want to try and maybe rename that a little bit. So let's go down that road and see what we get. in order to kind of press on, I do have to close this figure. If you notice on the command prompt, I've got kind of this open white square. It's basically in holding mode. It's like, I know you're looking at the picture. I'm not going to do anything else until you close the picture out. So I kill that, and we come back. That's kind of a limiting factor. And later on in one of the other examples, I'll show you how to kind of get past that. But for now, we're stuck with it. All right. So get back on the command prompt and run the next step. So we're going to do basically the same thing. But instead of having all those numbers aligned at the bottom of the bar, I'm going to align all of the numbers in the center of the bar. And we're just going to repeat and rinse. And now you see the 0 item is right there centered in the bar. So that's a little closer to where we want it. Makes it a little neater. But 0 doesn't really mean anything to my reader. So let's try and figure out ways to clean up some of that. Maybe put some names or some other data associated with that. Before we go to that step, that blue is kind of this garish, ugly blue. Hurts the eyes. Matplotlib plots fully understand the idea of an alpha channel, so you can have transparency. So I'm going to put some transparency using alpha equals 0.4 on that blue color, and it'll basically fade the blue a little bit. So let's see what we get. Now it's a little gentler blue. Let's see what's next. From there, I want to change the color. In retrospect, I didn't really like the color blue, so I'm going to change the color to R. R stands for red. They have several shortcuts. R, B, I think K for black, and a variety of other colors like that. G, I think, is green. Y is yellow. You can also use kind of the standard RGB color scheme. You can use, I believe, the hex color scheme if you're used to doing colors on the web. We use hexadecimal to identify it. So it's got full understanding of various types of color schemes. But if you're doing fast and dirty and you just want to put a couple colors in, red, blue, yellow, those all work just the way you'd expect. So let's try and change it to red. Because of the alpha transparency, it makes it kind of a pink color. And now I don't like that. Okay. And what if we want to have error bars? We know that the fan ratings, especially for some of the folks, the error might be a little plus or minus. And maybe depending on how many samples we have for each superhero, maybe those error bars may be a little bigger, a little smaller. So what I did here, I used NumPy's random function again to produce a small series of random numbers. Normally you would have real data. I had to make it up, had to make some fake data, but I assigned that to a function or a variable called error. And then in my function, I can tell it for the x values, the error should be drawn from this NumPy array with error values in it. So let's see what we get. And now, again, kind of hard to see, but there are these nice little error bars. One thing about this window that we have that pops up, it does have some buttons built into it, so you can play with your data a little bit. So I was able to click the zoom button, and I could zoom right in, and I can see, you know, the different error bars and how they got kind of the little arms at the end of them, etc. You can go right back to adjust. You can adjust your plot so you have more space on the bottom, less space on the top, etc. using these little sliders. Okay. All right. And you can save your data if you wanted to. They got a save button. I'll show you how to do that programmatically so you don't have to do it by hand. We'll do that later though. All right. So let's see what we got. That's not good. I have had some quirkiness with some of the matplotlib figures where if they don't close out properly, you get stuck in this limbo. So we're going to have to kill this in some horrible, horrible way. And we'll try and start over from scratch. So let me make sure I know where I'm at. We're in the right place. run and one horizontal. I'm pretty sure that was the end of what we wanted to do in there, but let me check. We might be able to go on just to the next demo. Ah, shucks. There's one more item. Dang it. All right. So you guys have to bear with me. We'll go through it. I'm going to go whiz bang through all the parts until we get to the very end. And there we go. All right. All right. And so let's kill that. So let me tell you, when I'm creating these, and I have several demos where it shows that thing and I have to kill it. And every time I do the demo and I change something and I go through it to make sure it's still working right, I have to kill those little things all the time. That was horrible. All right. There we go. And we're almost there. So there's the whiskers, which is good. And this should be, I think, the last one. So let's kind of tweak this a little bit. Let's put some X labels on it, some Y labels. Let's give it a title across the top of the page. And then let's save that someplace. So I basically do the same function, do the bar chart. We put all the other parts and pieces we had in there. But you can also interact with the plot directly and say, for the Y ticks, I want to marry up each of the Y position numbers, that 0, 1, 2, all the way up to 7, with somebody out of the people list. And it will partner every Y position on the graph with somebody out of the people list. Now this necessitates the two of them have to be the same length, which is why earlier when I did that calculation, Y positions must be a range with the length of how many items were in people. You can set labels for both the X and Y axis. Here I'm going to choose ratings, because these are fan ratings, how much the fans like each of these superheroes. We give a title to the graph, estimated Justice League fan ratings, and then I'm going to go ahead and save it. The default is to read the last couple of characters in your file name and save it as that type of file. So I don't even have to do anything like save this as a JPEG or save this as a PNG. When I type in the file name that I want to give it, it automatically looks at the end and goes, oh, Chalmer wants PNG. Sweet, we'll do that. If I had put JPEG, it would read it or save it as a JPEG. So that's kind of sweet. All right, so we save directly, and I go in there. We get that nice chart. And we see at the top it has the title that we added. We see on the left-hand side we replaced the numbers with the names of all of our superheroes. Kara's in there, Kyle and Barbara. All right. And then all the numbers. And we got a rating on the bottom for the X label. We chose not to put a label for the Y just because we were feeling persnickety. So that's the first one. The other charts that we're going to look at tonight are very similar. Kind of the parts and pieces in the process will be similar. I'm going to give you some thoughts and hints and tips as we go through to maybe how to handle pandas to get certain data that you want, how to manipulate data. We'll talk a little bit about some of the differences between the charts. But before we go down that road, I want to show you something. Let me pull up my browser, and let's go to search for matplotlib gallery, right? And we'll see what you can do with matplotlib. So this page is actually going to take a little while to load. It's still loading in the bottom. You're going to see all these little tiny thumbnails. Each of these thumbnails is a particular type of graph that you can make. And you can see there's a wide variety of them. There's kind of polar coordinate types of graphs. There's elliptical graphs. There are histograms of various sorts, heat maps on a bolt scale, and heat maps on a very fine-grained scale. You have kind of flow charts where the thickness of a line might represent some detail of the flow. You've got scatter plots, which we'll look at, more polar graphs. This one over here, far left, where my cursor is, that's basically like 4 types of graphs. They all have something in common. You put them all together in one sequence. Whisker plots to show kind of confidence intervals or those types of things. Heat maps and contour maps. Pictures. And I'm only halfway through the thing, right? We got heat maps maybe representing crime statistics in a city. Which road in a city has the biggest problems? I don't know. Kind of these pie-shaped wedges, different polar coordinates. This is kind of shaded data, so it looks almost three-dimensional, etc. And then we go down into some three-dimensional plots, so you can add even more data to your. They have a sequence of widgets. We're not going to look at those tonight, but some of the widgets that you can add, for example, to a web page, allow you to interact with your graph in real time. Okay, all right. Now, here's the cool thing. They not only have this graph or this picture, but when you click on any one of these things, they give you the code that they used to make that picture. So it's got basically built-in kind of tutoring for you. Wow, I really want a histogram, but I'm not sure what to do. And a number of these have been commented, so it gives you a little bit of help as to why they're doing it, what the purpose is for a particular step. You can download the code directly. They've got the source code available to you. If you just want to see the picture because you're putting together a presentation or something, and you want to demo that, hey, this thing is available or whatever, they've got PNGs of each of the graphs. They have a high-resolution version of that, and they got a PDF version as well. So lots of good stuff in the matplotlib library. And you'll find that for pretty much all of the visualization tools we talk about tonight, they all have a similar gallery. Bokeh's got one, Seaborn's got one, etc. All right. So let's go on to demo 2. Well, if anybody has any questions. Any questions before we go? All right. Again, I'm pulling in some libraries. We're going to start off with NumPy. We don't need pandas in this case, so we skip the burden of importing pandas. We have 2 parts to matplotlib that we're going to use. The mlab module and the pyplot module. And they're going to help us do different types of things as we go along. All right. We're going to set up a couple initial variables. We're going to choose a mean of about 100 for our data set. Sigma, the standard deviation, is going to be about 15. And we're going to create some data. I'm going to use the random number generator from NumPy. Give me 10,000 random numbers. I'm going to add multiply each of them by sigma to give us a little bit of range, and then we're going to add that to the mean, so that way we'll have a nice kind of distribution around 100 with a standard deviation plus or minus about 15. All right. And then I tell it to print that to the screen so we can see what it looks like loosely. And I also tell it that I want 50 bins. We're going to bin this data into sections so we can make a nice histogram. So we're going to have 10,000 pieces of data, but we want them to fit essentially into 50 different columns. All right. When I print it out, something to note, I have 10,000 values here, but Python chooses to show me only a selection of them. It's got these ellipses in the center to tell me, Chalmer, we're not showing you all the data. There are ways to kind of override that default behavior in IPython. It's a setting they have in the configurations. It is very useful because many times if you're using IPython, you're typically looking at larger functions of data. So if you've got 1 million rows, maybe you only want to see a handful of them to kind of make sure the data read in properly. Maybe you want to see the beginning rows and the last rows to make sure you got all of it, but you don't really care about the stuff in the middle. So you don't want to see it scroll for, minutes or seconds or minutes on end. Num bins, we see that that's 50. All right. The PLT package has a function called hist for histogram. And in here, I'm going to give it 5 different parameters. I'm going to tell it the data to plot, which is that X that I generated. And again, that's 10,000 values. They're centered on 100. I tell it how many bins I want to break this up into. I tell it I want to have it normed. And I tell it that I want it to be a green in color. And I want the green to be kind of translucent. So I give it an alpha of 0.5. In this case, I'm going to ask it to print some of the results of this function. And this function actually produces 3 things. First, it will produce n, which would be the heights for each of the bar in my histogram. So I have 10,000 values, and 100, for example, is going to show up a lot. So that n will show me how high each of my bars will be. It's going to show me where the bins break off. When it broke up all the values into 50 bins, it'll show me the lowest bin starts here and ends here. The next bin starts there and ends at this higher level. The next bin starts here and ends there. So we can actually see how the bins broke out and make sure that our data seems to be fitting in the right direction. So we'll see the bins. And then it produces a set of patches. And those patches are actually the little rectangles. And it produces an individual patch with parameters and characteristics. And later on, when it goes to plot this thing, it'll slap each of those little rectangles onto the graph for us. All right, so let's run this. It should print some stuff in the terminal, and it should make a graph. All right. And that's not what we wanted. There we go. All right. So I asked it to print 2 things. The first part was print all of the n values, all of these heights above 0 for each of those little bars. And they're in scientific notation. And next I said, I want to know what those bins break out to be. My lowest bin starts at 39, goes to 41. My next bin starts at 41, goes to 44, 44 to 46, and it works its way up. And if you were to kind of do the math, you would find that they're all essentially equally spaced. Okay. So we'll kill this graph, and we'll press on. So next, I essentially do the same thing, but now I want to add a layer to this. That MLab library that we were looking at earlier has a function built into it to produce probability distributions based on a normal curve. So I tell it how many bins we have, I tell it what the mean was and what the standard deviation was, and it makes a nice bell-shaped curve. And then I'm going to ask it to plot the bins and the y values, make them red. I use R. And that R code has got 2 extra characters in it. You'll see variations as we go through the conversation today. The first character after the R tells it what symbol to use, whether you want to use a circle, a triangle, a square for each data point. And then the last symbol we give it is whether you want it to be a dashed line or something different. In this case, we're going to go with dashes. So it'll make a nice plot on my figure. Gives me all my bins, it gives me that curve, and it will still show, because we had already generated using this histogram command, it'll still show all of those rectangles as well. So we should get 2 parts. And there we go. It's probably a little hard to see, so let's zoom in. Got nice red dashed line. Okay. And let's close that and hope that goes away. Next. Whoops. Awesome. We basically do the same thing. We change color to blue. I give it a label. How smart is the average person? That's what smarts means. This is supposed to be IQ test results or something silly. Probability of somebody falling into that category based on the probability distribution. So again, we can kind of tweak these graphs any way we'd like. Go away. All right. So bless its heart, my laptop is flipping out. That's always bad. The next thing, we saw before that we could add a title to it, right? But you have a great deal of flexibility in how you configure the title. In this case, I give it a string, and there's an R in front of the string. That means that I want this string to be interpreted as a raw string. If there are any backward slashes or whatever, I want them to be interpreted as backward slashes as opposed to escape characters. So that's why I'm telling Python to consider it to be a raw string. And in this case, I have 2 backward slashes and a couple other symbols in there that we need to care about. Right in front of the word mu, I have a $sign and a backward slash. And for matplotlib, if you use a $sign and a backward slash, that tells it that you want to have something in italics. And you basically give it an end tag of another $sign. So my mu equals 100 should show up in my title as italics. Same thing for sigma equals 15. And that. And might be a little hard to see, but up at the top, it actually does produce mu as a Greek character. It recognized that for us, and it produced it in italics. All right. And I think that's the end of that show. Nope, there's one more. All right. Bottom, I use this subplots adjust feature. Sometimes when you produce a graph and you're trying to produce a picture that you're going to put into some sort of presentation quality, an article or a briefing or something like that, things don't quite line up the way you want. You saw earlier that I can kind of change where a plot shows up on the picture using one of those buttons that was at the bottom of the figure. You can also adjust the position of those subplots, shift them a little to the left, shift them a little to the right, shift them up, down, etc. So in this case, it's going to shift. We won't really be able to tell because we don't have anything to compare it to from the beginning. And then at the end, I'm just going to tell it to save it as hist.png. And all right. Modern technology is failing me today. Where'd it go? It does not want to bring me back my Finder. Dang it. All right. Take my word for it. All right. So what questions do you guys have? Any? Nope. All right. Let's go to the next demo. This one is a scatter plot. A lot of the same rules apply. We do the imports, NumPy, pandas, etc. I'm going to read in from a CSV file. In this case, it's very similar to the one we had before. It's going to have names. It's going to have email, from IP, to IP. It's going to have a column with dates in it, lat longs, a payload size. This one is log file underscore 1000. It actually has 1,000 rows of data instead of just 10. I have n rows equals 35. This is me telling pandas, yeah, I know the file had 1,000 rows in it, but only grab 35. So you can actually be very, conservative about the type of data that you read in or how much you read in. And then lastly, I tell it, yeah, I know there's like 8 columns, but I only want 2 of them. I want the latitude and the longitude columns. So just give me 35 rows of lats and longs, starting from the top. And if we ask it to show us that, it starts counting at 0, it goes to 34, and the columns are lat and long. All right. I'm going to grab each of those columns individually, and I'm going to store them with their own name, latitudes or longitudes. And let's go ask Python, what is this thing that I have gathered? And you see that it's a series. It's basically just a pandas column. All right. I want to ask, well, how long is that column? So we'll store that as count. And we'll see the count is equal to 35. And then I'm going to create a series of random numbers. I start off, I pull out numpy, and I ask it to give me a value for pi. And it will give me pi to 15 decimals. I pull out the random function, and I tell it I need 35 values. Again, I believe they come out between 0 and 1. And I tell it to multiply that by 20. Take that to the second power and multiply that by pi. And we end up getting the area of a circle. I'm going to store all those areas, and we are going to use those later to help us define the size of the circles on our scatter plot. I call up PLT and I say, hey, show me a scatter plot. All I want to show is latitude versus longitude and the areas of each of the circles should be from what we calculated a few minutes ago. And colors should be a series of random numbers. I didn't mention this earlier, sorry. I said give me 35 random numbers that we can plug in as color indicators. Again, I told you that there's several ways to define colors. You can use R, Y. You can use decimal values. You can use hexadecimal, etc. And in this case, we're basically using some sort of decimal value to identify colors. I think it comes out mostly in the grays. All right. So we produced this thing. It's a matplotlib collections, path collection, blah, blah, blah. We haven't displayed it yet, but it's stored in memory. All right. Now that this thing is stored in memory, I'm going to save it. I'm going to save it with the title of scatter.png. And I'm also going to ask it to then show it to us on the screen. And there we go. And somewhere in here, my number values got hosed up. That's awesome. And they're all lumped over in one little corner. I wonder where we went awry. Oh, I know why we went awry. There we go. Tricky when you try and close out a figure and then generate a new figure. It was trying to generate some of the new data onto the old graph. And the old graph had numbers from like 0 to 150. So it's putting everything between 44 and 51 over in that one little corner. All right, so we got a nice scatter plot. In this case, they all turned out to be different colors. The size of the circles came out to be random. And this might represent something like size of a population for a given city at various latitudes and longitudes. And maybe the color might represent kind of the average age for the people in that city or whatever. So there's a variety of pieces of data you can put on a scatter plot. In this case, we can show essentially 4 different types of data: horizontal, vertical locations, or horizontal and vertical values. And then we can use color and size to identify some other additional relationship. All right, so let's kill that and go on to the next thing. And that's the end of that one. All right, we got one more demo, and then we'll talk about a couple other things. Any other question or any questions? All right. And this will be demo 4. This is a subplots demo. We pull in matplotlib, we pull in NumPy. In the NumPy library, they have a linspace function that allows you to create a sequence of values and separate them into a certain number of these spacings. So I'm telling it to start at 0, go all the way up to 5.0, and basically create 200 numbers total. I'm going to do this twice. So I'm going to have some x1 values and some x2 values, because I'm going to put each of these on 2 separate graphs. It'll be one right on top of the other. There is a note here in the comments, and it says, if I wanted to, since the right side of this equation is exactly the same on both these lines, I could have typed it x1 equals x2 equals np.linspace. That's perfectly legit. It works just fine, just like you'd expect. It's kind of personal preference whether you want to do it or not want to do it. I tend to avoid doing it even though you can. And even though it kind of saves a line of code and all that. Simply because for me, when I read my code and I go looking for variable names, I tend to look on the far left of the equal signs. My eye just kind of skims down to find a variable name. I don't expect to look on the right side of an equal sign to find a variable name. So if I had, 3,000 lines of code and I'm kind of skimming around for various things, scrolling up and down a little here and there, I might miss the x2, and that just frustrates me. But it works. It's legit. All right. I'm going to run 2 sets of calculations to produce a set of y values to go with x1 and a set of y values to go with x2. We have in the NumPy library, we've got a cosine function. For every value in an array that you give it, it will take the cosine of each of those values. We've got, again, pi. We saw that before. And we've got a natural exponential function. For every element in an array that you pass to it, it will take the exponential function. In this case, I'm not going to go into the math about how and why it does it. It will produce a dampening effect, and it will cause my graph to oscillate less widely. And we'll see that. I'll let you guys study out the hows and the whys of it doing that. All right. Here I'm going to turn on plot.interactive. So I run this function, interactive, and I put true in there. And what this is going to do is it's going to produce my picture on the screen. And I can continue to work on the command prompt instead of having to close that picture. And I can continue to tweak and add things to the graph as I go. My next step is I'm going to tell it I need a subplot. And I tell it how many rows, how many columns, and which of the plots that I generate should be the active one. So I'm going to tell it I need 2 rows, I need a single column, and the first plot at the top of the column is the one that I want to be working on next. And you can go and change your active one, so you can fix this graph and then go work on the second graph that's below it, or the 4th graph that's off to the side. And you can make these subplots quite complex. I've seen cases, I think, where there's 16 subplots all in a single figure. All right, so here we've produced it. It gives me a blank canvas on the top. I haven't told it to do anything with the second subplot, so it leaves it blank, but eventually we're going to have another white box there. Let me move this off to the side a little bit, and as we go along, we're going to watch this thing change in real time. Okay. So I'm going to tell it, look, I want you to plot x1 and y1. I want you to make it yellow. I want you to use little tiny circles. And I can't remember what the dash is. It might mean dashed lines. But on this graph, everything's going to be so jammed together, you're not going to notice it. For my next plot that I want to generate, I'm going to tell it use the x2 values and those y2 values, make it red, and instead of little circles, make it little tiny dots. We're going to put a title at the top of the plot, and the y label will be damped and undamped oscillations. So let's do that. And we see that, again, we're only working on one plot at a time right now. We're or one area at a time. So it produces the two things. It gives me the little red dots, gives me the yellow circles, gives me a nice title for my entire thing, and my Y side's got a label. I don't have any label for the X yet. Since I'm going to have multiple graphs on the same kind of sheet of paper, I might want to put just a single label at the bottom since we're expecting all the Y or the X values to line up neatly. But if I wanted to, I could have a single X label for the top and a single X label for the bottom image. So now I'm telling it, go to subplot, 2 column, or 2 rows, 1 column, go to the second plot that's available to us. That's what the 2 at the end of this is for. And this time I tell it, take X1 and Y1, put them on a graph for me, use the green color, and use little tiny triangles. That's what the caret symbol gives me. And my X label that will apply to both these graphs will be time in seconds. And the Y label would just say that this one is damped. So I'm only going to have a single set of data show up. And there we go. And you see the kind of the oscillations dwindle down over time. All right. Now I want to kind of tweak some of these ticks. So my X ticks for the second image that I created, they have numbers associated with them. I might want to change that. So I'm going to tell it, for every X tick in this NumPy array, going from 0 to 5, I want you to change that. And I want you to give it a name of 0 with letters, 1, 2, 3, and 4 with letters. And then I want you to save the picture. Okay. And we see that we changed the tick marks. So now instead of saying 0, 1, 2, 3, they actually have words. Kind of silly, but nonetheless. And that's the end of the 4th demo. So before we go talk a little bit about Seaborn and Bokeh, what questions do we have? All right. So let's go look at Seaborn. So Seaborn is a library that in many ways just builds right on top of matplotlib. A lot of people looked at matplotlib and they said, this is a phenomenally powerful library and this is really, really good. It does a lot of great things. We love it. But for the newbie to dive into matplotlib and produce a highly effective plot can be a little bit daunting. There's a lot of things you can tweak and change. And there's also some aspects of just doing good visualizations that are tough. What are the right colors to pick? What are the right things to put? What are good proportions for things, stuff like that. So I said, you know what? We can try and simplify that. And that was kind of the genesis of Seaborn. When you use the Seaborn library, it basically separates you from matplotlib. And you can tell it that you want to generate a particular type of graph. It will use some default color schemes for you. Color schemes that are kind of pleasing to the eye. They're not very jarring. They might have good contrast so they display well, etc. All right. And you can see the example gallery that Seaborn has is a little bit less extensive than the one they had for matplotlib, but a lot of the ones that you might be interested in are there. They've got scatplotlib or scatter plots. They've got a scatter plot with regression lines on it. So you can actually funnel regression information right into Seaborn. And not just regression information, but if you look at this one, it's got the regression line, and then it's got kind of this bounding bars on either side of it to kind of show the error. It's got these marginal distributions that can be laid on either side of it. So they take some of the most popular and most widely used graphs, and they kind of build them for you. Uses a nice color scheme, the dark red line, kind of the paler pinkish or salmon color. And just like matplotlib, they give you the code that you would use this. So in this case, let me see if I can blow this up a bit. Import Seaborn. By default, it's customary to import it as SNS. And you tell it, set what type of style you want it to use. In this case, they chose what they call a dark grid color. Whether they should use color coding or not, turn it to true. They have a built-in data set that comes with Seaborn. So you can load the tips data set in this case. And you say, you know what, I want to do a joint plot. And I want to use just the columns total bill and tip out of the data set tips. I want to have the regression line. The limits for my X and Y should be between 0 and 60, 0 and 12, whatever. Use the red color, size 7 for. And again, it kind of helps take away some of the difficulty of producing all of these things. All right. And let's go back. Heat maps, box plots with the little whiskers. And again, you tell it, hey, I need a box plot, and you give it about 4 or 5 items, and that's it. You tell it, from this data set, tips, use the day column as my X values, use the total bill column as my Y values, use particular hue assigned with gender, whether it be male or female, and then use this particular palette, the PRGN palette, and it kind of chooses how to break this out. And that's it. So, pretty good. From there, the other one I wanted to kind of mention to you is bokeh. Let's see if bokeh's got a gallery. So bokeh's got a wide variety of examples as well. Kind of a similar thing here. We can get it to load. So you've got a nice scatter plot. We've got kind of histograms on either side. And this is interactive. There are certain tools that are in here, like they have a pan tool. They've got a lasso select tool. So if I wanted to select just a subset of this data to kind of do some analysis on, I really want to see how my mousing skills are pretty awful today. I want to see how this data shows up. You see that this part down here is highlighted on my distribution, and this part is highlighted. If I want to capture all these guys, we can see kind of how that data that I've selected for kind of highlighting shows up in our histogram, and how much of an impact that data has on the histogram. I don't have a zoom mouse, but you can do wheel zooming, etc. You can do box selections of stuff. All right, so I'm going to see just these items in this area. And all the bokeh libraries are like this. They have interactive features built in, so that when you produce this and you put it on a web page someplace, your user can actually dive into it and can play with it. Some of them will have the ability to zoom in nicely the way you would want. So like you've got 10, huh?
You can zoom in with your little 2-finger.
Maybe. And my little 2-finger thing is zooming in. Look at that. So if I just want to see a subset of the data, let's turn on the pan. And you can pan around. So that's bokeh. Let's go see if we can get another example. Let's kill that one. Let's see. I haven't played with this one, so we have no idea what it's going to do. All right, this one has a few additional buttons. Still has the pan button, so you could zoom in or scroll around if you need to. It's got a box zoom. Let's try and do that. There we go. So here, if we want to look at different types of bacterium or whatever and their impact on folks, we can zoom in and out. And we can resize this thing to fit kind of however we want it to fit on our web page. If we want to preview this and save it, we can do that. If we want to reset things, it's got a nice reset button. And again, just like with Seaborn and matplotlib, all the code that you could possibly use to create this is there. They use pandas and NumPy and a variety of other things. Huh? Mm-hmm. Mm-hmm. Yep. All right. So that's that. So those are the things. It's pretty much what I wanted to show you guys in terms of like data visualization. There's a lot of cool things you can do. Some are more whiz-bang than others. Some are more robust and have been around a longer time. Bokeh is fairly new to the environment. Seaborn is kind of new as well, as far as I know. I just used Seaborn a little while ago. If you want to see a couple of examples of Seaborn, I've got a graph or two that I made for a college project. So I've got dark art data science on WordPress. My kid and I are making some data science blogish entries. I have a visualizing data page, and this is Seaborn in action. I produced 4 different plots, and then I've got code down at the bottom of the page. Most of it's kind of commented, so you can tell what's going on, and I show you all the ways to make all of those graphs. So if you want to dive into Seaborn, that's another avenue to get a couple of examples.